Guys, you know the secret to solving complex and sophisticated exponential equations such as this one is all about using the log laws. And that's what we're going to use in order to solve this. We're looking for x and the answer will be an approximation. So how do you find it without log laws? Well, it's pretty hard. You can't just guess and check this because it's a pretty big decimal there. So log laws is the best way to go about it. So the first thing before we apply the log laws would be to try and take this decimal here, this very long one, and transform it into a fraction. So let's do that first of all. So that as a fraction, it's pretty easy to work it out. You just go to your calculator and reciprocate it. In other words, x to the power -1 when you inverse it. So let's do that. So that would be the same as 1/4000. Okay, 6 to the power of x equals that. So let's write that up. Let's solve for that x. Now what can we do? Well, we can also write this down with a power over there, an exponent, and that could be written easily as to the power of -1. That's exactly the same, isn't it? Now we can start to apply the logs. Now the log we're going to apply would need to be to the base 10 or a favorable base that our calculator is familiar with, perhaps natural log, exponential e, for example. So we're going to use base 10, log base 10 on our calculator to solve this. So what I'm going to do is, before we do that, is log both sides because it's an exponential equation. So let's log both sides. So all I have to do is write out log. Here's our base 10, 6 to the power of x, and that equals, again, log to the same base to the power of -1. Okay, it's all balanced, it's equated, and now we're going to use another log law, and that's where we use the power law. That's where we can take the power and bring it to the front. Similarly, on the right-hand side, we can take the power of -1 and bring it to the front over here. So let's go ahead and move those powers to the front. So that means this side is going to become there we go, there's our equation. Now all we have to do is put this x right over here, the variable, make that the subject. So this will be the subject. So what I'm going to do to balance both sides is divide both sides by this here, log base 10, 6. So let's divide both sides by that and make that the subject. I'll put the -1 there. All we have to do is plunk that in the calculator. Now this part here, you can't take a negative log. What you do is you go log of 4000 and then just add the negative sign to it later. That way you can't get an error. And then down the bottom here, just go log 6. And of course it's going to be base 10. That's what the calculator, my one, is using anyway. So let's plunk that into the calculator. So once that's plunked in, we're going to get some pretty big decimals. I might write some of them in for you. So on the top, we're going to have negative, whatever the answer is. So you go log 4000, and that's going to yield an answer of and log base 10, 6 on the calculator. That's going to give you And these are depending on the number of digits your calculator screen has. So that's an approximation, so let's put that in. So that's going to give us a grand total. The final answer, solving for that x there, that's going to be and I'll just do it to 3 decimal places. Now you can check to ensure that you got the correct answer. And mind you, again, I'll say it again, it's an approximation, so relax if yours is slightly different on the decimal points there. So all you have to do is take this, substitute it into that to check and make sure 6 to the power of negative 4.629 gives you something very close to that. It will be an approximation and won't be exact. The more decimal places you use, the more accurate your answer will be. Thanks for watching.